What we're going to be talking about today is not the daily data entry, but we're focusing on the pre-meet inspection, and in particular, the issues associated with the grades and design of the track. A lot of this documentation hasn't been standardized, and this is, again, just like everything else we've seen with HICE, we're beginning to think about how we can standardize this and understand the risk, because this is important to the safety of the horse and rider. So the first person who's going to talk is Branden Brookfield, who is going to talk about what to expect when he comes to the track to do the pre-meet inspections. So the pre-meet inspections are done typically 2 to 4 weeks before you start racing. You have to be ready for racing. The surface has to be ready. A series of tests are done. If you have a long meet, if you have essentially, you know, a parks or one of the really long meets, you do it before the start of the winter and before the start of the summer, especially if you're changing over the track and, you know, recovering from the spring where you had to add a lot of salt.
Morning, everyone. As Mick said, my name is Branden Brookfield. I am the Onsite Testing Manager with Racing Surface Testing Laboratory. And today I am really going to go through what on-site testing includes and what that is going to look like when I show up on your racetrack. So starting out, why does our on-site testing look like it does? And so a lot of what we have been doing, especially these last year, is pre-meet inspections. We are showing up, as Mick said, 2 to 4 weeks before your race meet starts, and we are going through and trying to fulfill each of these. And so, yeah, so we are going to be looking at geometry of your track. We're going to be taking grades, looking at the slopes. We're going to be trying to figure out the accuracy of the distances. We can GPS mark your poles. We're looking at cushion and base geometries. We're taking those measurements at every 8th pole as we go around. We're doing a base inspection. We are using ground penetrating radar to do that, where you are not having to take a large windrow out of your track to get down to your base and inspect it. And so we're being able to look at it that way. We're looking at the mechanical properties of your racetrack using the orthobiomechanical surface tester. The surface materials, we're going to collect some samples, take it back to the lab, and you'll get a report on that as well. And then we are also trying to fulfill these 2 bottom mandates here, the rail inspection and the track design records. And so this is all for the dirt and synthetic. For the turf, it's just slightly different. Mostly looking at the turf profile and turf species. We also want to take some samples there. And so then how are we fulfilling these requirements? As I said, we're using the orthobiomechanical surface tester to look at the different properties of your racetrack, how it responds. That machine is going to be replicating the leading forelimb of a horse at a gallop. And so it is a standardized way for us to test across many different racetracks. Again, the ground penetrating radar, where we can look into the layers of your track and not have to do anything really heavily invasive. The rail inspection, we're going around, we're walking the surfaces, making sure that everything's at a relatively standard height and that we don't have anything like we see here where there's gaps. And then we're doing the surface cross-falling grades as well as checking the marker poles, as you can see there in the far right. So first things first, when we make it to your track, what do we need? We need a race-ready surface on your dirt or synthetic. And so what is a race-ready surface? A race-ready surface for us is going to be prepared as it would be for your first post. We don't want any changes. We want to make sure that you've really got all the hoof prints out if you've had morning training, and that everything is as set up and as perfect as it can possibly be. The biomechanical tester, we call it the OBST. It is fairly sensitive to changes. I mean, we're looking at variations of a 1/4 inch and seeing disparities with that. And so we really want to make sure everything's set up as best it can. Also, we would really appreciate that we don't have a change in daily routine. If you change the depth on your harrows, you change the speed at which you're driving, you can start to create problems, which makes it not as accurate a representation of your track as you would probably like. And then we also need it to be classified as good. We can't test a sloppy surface. I don't think you guys would want us to test on your sloppy surface. It's just not going to give any good data. And so to start out, we usually begin with the OBST. We are doing 3 drops at each 8th pole in the 7-foot and 15-foot lanes of your racetrack. And so you can kind of see that here. Your blue is going to be your 7-foot drops. Your white is going to be your 15-foot drops. It's 2 laps. And that'll take us roughly an hour to get done. And so why are we testing at these locations? Well, it's going to accurately represent your racetrack for what most of your horses are going over. You know, it's racing lanes. We want to be down there closer to the rail. And that is really what we are concerned about, is when your horses are up at speed. Testing at 7 and 15 really make sure that we cover that. You know, if you've got larger field sizes, if you've got 10, 12 horses running, you're obviously going to be out just a little bit farther than that 7-foot location. And the 3 drops at each location really just allows us to look at variation both there at the pole and then variation over the entire track. And so what information is our OBST producing? You're going to get 3 different measurements that are going to be in your on-site testing report. You're going to have your cushioning, which is your vertical load. You're going to have your impact firmness, which is the deceleration. That's going to come to you in a G-force. And then you're going to have slide, which is your horizontal. And so all 3 of those will be, you'll be able to see how your poles stack up against the points local and then across the racetrack. And then for turf, we are actually going to use the penetrometer, which is a little different than the OBST, but a very similar concept of looking at the penetration depth. So the next thing we're typically going to do is we're going to go to the ground penetrating radar. Once we have finished with the hoof tester. And so for that, we would prefer that the surface be sealed in some capacity, whether it's with a roller, you float it down. It just makes that antenna bounce a little less. That's going to be the white piece there. And so the less that bounces, the better it's going to make your track look. Obviously, this is going to be able to see down. We can see your cushion layer. We can see a pad layer, hard pan if you've got it, and we can see your base layers. And we can do all that without having to really disturb the surface. But having that nice, smooth ground to go over certainly helps us get that image better. And the best part that we like about this is it allows us to take an extremely large amount of data in a relatively short amount of time. From us dialing it in to being done takes roughly an hour per surface. And we are taking a measurement at every 4 inches around your racetrack as we drive. And we're going to do a total of 4 laps. And so that's obviously quite a bit of data points. It's a lot more than you could do taking hand measurements out there, and it's much more efficient. And so what does this produce? For us, we're going to see this picture here when we go through to process this data. As you can see here, the cushion layer, which is going to be these smaller yellow dots at the top layer, it's roughly about 3 inches. We've got a scale on the left-hand side there. We can also see the base layer here at roughly 8 inches. And so we're going through and looking at these layers, we're trying to see anomalies. If we see anomalies and things in there, we can notify you guys, and we actually have it with GPS data. And so we can tell you exactly where on your racetrack that is. It's not a guessing game. It's not, okay, it's roughly at the 8th pole. We can tell you fairly specifically where that's going to be on your racetrack. And so then after processing the data, you guys are going to get a much cleaner version of this. This is not what you'll look at in your report. You're going to get a nice overlay of the track with a color map, which is going to be a little bit easier to read than trying to go through here and look at 5,000 feet of data points. So after we get done with that, and this is the part where I like to say that you guys can really have your racetrack back. Normal maintenance can resume. I can dodge you and really make sure that I'm out of your way. And so I understand, I worked on crews at Keeneland. I understand you guys have a lot to get done. And so in roughly 2.5 hours of the testing, you guys can resume your normal maintenance and really get back at it. And so as you guys resume, I'm going to be taking grades. And so we are using just the tripod laser here, and we are checking it at each 8th pole. And we are just checking crossfall. We're not necessarily doing rise and fall of your racetrack. We are checking crossfall at the pole locally. And so we are going to do that in 10-foot increments. That's, I think everybody in their folder has the data sheet we use for that, correct? And so you guys can kind of open that and look there. We're going to check it 0, 10, 20, and 30 so that we can see your grades as we go across that inside racing lanes. And then this is what you're going to get when we are all said and done. You'll have a very similar picture to that in your report. And it allows us to determine your average slopes, look at standard deviations, make sure that you're consistent around your surfaces. Obviously, that's our goal right now, is consistency. While we're doing that, I'm also doing rail height and pole distance. And so as I'm getting to each 8th pole, I'm taking the GPS location of that pole. For us, we can go back into Google Earth and we can actually plot that and overlay it as you see here on the right. And again, when looking at the rails, we're really just trying to make sure there's no gaps. We've got a standard height somewhere between 38 and 42 inches on these steel in-ground rails that are permanent. And as I said, there's just nothing hanging, no wires or any sharp edges that you could hit. So how is this information going to come to you? You are going to get both of these charts here. It's going to show you the distances between your poles at each 1/8 of a mile here, so 660. And then you're also going to get the rail height on your left there. And so for us, this is a great way to look at consistency. If we have a spot that's different, it means that we probably want to take a little bit more of a look at it. And then obviously the marker poles for you guys setting up the timers and things, it's important to make sure that you have them where you think you have them. After we get done with the grades, we're also taking samples as we're on site. And so depending on your track is going to be dependent on how we take samples. For dirt, we are taking 7 standard samples for anything over a mile and during on-site testing. So if you are a training track, we're just generally hitting your quarter poles, generally a little bit smaller. You can get a much more accurate representation with fewer samples, even though just because of the smaller surface. Synthetic, we're also doing quarter poles at 7. And then the turf, we're doing quarter poles at 3 and 28 as the rail tends to move for most properties. So how are those results going to come back to you? That is going to be a report separate from on-site testing. When I make it back from my trips out to the lab, I'm handing those off to other people within our organization, Pat and Andrew, and they are looking at the salt, silt, and clay percentages of your racetrack and of that sample. The different samples that we take allows us to compare across your entire surface. And so if you have spots that are different or areas that are more affected by erosion, we're able to see those differences and then advise on how you guys can help them. And so, as I said, a huge factor affecting that is going to be drainage of your racetrack. If you've got large drains in an area or a place that continually likes to run off, most of the time that area is going to come back slightly different when we run the tests. And these results are going to be provided in a composition report. As I said, that's going to be set out separate from the on-site testing report, but shouldn't be too long after we were on site. The final thing that I'm going to do while I'm out there is check your weather stations if you guys have got one on your property. Really don't need anything from you all on that, and generally it's not on the track. So I will be completely off your surface at that point. I'm going to be just checking your rain gauges, making sure everything's on, and making sure that you guys are receiving data so that you can make decisions when you come in the morning. If we want to cut the track open, you can open it, see if you how much rain you got in the night past, and make that educated decision from that point. And so where are you going to? Okay, the next thing I'm going to do is the maintenance manual. This is going to be something I do when I get back to the lab. It is kind of development of a standard operating procedure for your racetrack. The biggest thing that we see in this is knowing where to find it. And so this is just a snippet of the MQS page once you have logged in. And as you can see, it's going to be right here on your homepage for maintenance manual. Once we have that completed, it will just appear on this. It's not going to be something that's sent out formally to you. And so then what kinds of things are we putting in your maintenance manual? Well, we're trying to figure out how you are taking care of your racetrack. And so we want to know the equipment, the depths, the speeds, how you're running it, certain patterns. If you have a way that you run your brakes, or you have a way that you open the racetrack every day, those are all really helpful things for us to note. And then you can see here in the top, this is what your maintenance manual is going to look like. It's going to have your equipment and what it is, how many of them you have, anything specific to your setup. And then the more information that we can get, the more information we're going to provide back, as far as what you're doing daily with that equipment. We do this also for the turf. It will be included. The turf, we're wanting to see if you have anything specific to the turf, as far as a turf tractor, aerators, vertidrain. If you have a specific spreader that you like to top dress with, those are all things that we want to include in your turf report. And so just a little bit of a recap here on what the on-site testing day is going to look like. We are going to start out with the OBST on that race-ready surface. It's going to be about an hour and a half for us to get that done. After that, we're going to move to ground-penetrating radar. You guys can seal the track at that point, resume watering if you need. And that's going to take us about an hour per surface. Once we move on to sampling and grade and rail inspection here, you guys can completely have your track back. Whatever maintenance needs to be done can be done at that point. We'll make sure we stay out of your way. And then the final thing I'm doing while I'm there is checking your weather station, making sure that's cleaned out and that you guys are receiving all the data that that's going to provide you. And so then when are you going to get your results? That's probably the question that you wonder the most once we leave. For the maintenance manual, as I said, it's going to appear on your MQS when we get that done. It's typically pretty close to when your on-site testing report is going to go out, and that report's going to go out in about 3 to 5 days. The track sampling and composition results, that takes a little bit longer usually. If I'm out and I have 3 tracks that I'm going to hit while I'm on the road, those samples don't actually make it to the lab until I make it back. And so it's about a 7 to 10 day window on those samples. And overall, that is what our day on-site testing looks like. Do you guys have any questions?